And today, I'm going to talk about Swift 6.2. And before I do, just a short introduction for those that don't know me. This is RocketSim. That's the developer tool that I developed to make you all more productive. And I also run a blog called Swiftly. It's my best streak so far, as you can see. Quite a few articles there. You might have read some of them. Now, Swift 6 is quite new, Swift 6.2 as well, but we migrated already to Swift 6.2. Okay, well, that's great. I'm here for a purpose. And we enabled strict concurrency because that is available for a bit longer. Okay, I'm not too surprised, and it's also the reason why I'm here. Who did this? Hey, I did too. You know, we can be honest, and it's fine, right? Like, you try to migrate and you see a lot of these warnings, and main actor all the things is kind of like a solution to many of those things. But let's go a little bit through the journey. I remember seeing this vision document in 2017, and I was like, hell yes, you know, no more closures. And I started to look forward to it, and then WWDC happened, and then WWDC happened, and then WWDC happened, and then WWDC happened. It took way too long, isn't it? But we finally got it, and this is very much the start, right? You get a new API to use, but before you migrate all your code, and before the standard API is supported in a well enough manner, it was very much the first version. And they built it forward to what they call the Swift 6 official release. And they really hope to have like thread safety, data risk safety with that release. And they had a certain mindset with it, and they thought like, okay, this is probably how it should work. But they're human too, and I'm talking about the Swift team here, and they realized like, okay, we thought some things would work like this, but it turns out in the real world, with real app projects, it works a little different. So February 19, we had another vision document, and this is the first time you see about them talking about the approachability of Swift concurrency. And that's also why I'm here today. Because with Swift 6.2, the official release, we actually got approachable concurrency. So if you go to the Swift evolution proposals overview and the ones that got implemented, this is the list for Swift 6.2. These are all new Swift features that we got during WWDC. And I want to highlight a few. But you need to realize that all these changes, even though they are here today, they're not enabled by default. And our projects are not always prepared for it. So even though those changes are for the future, they are a battle for today, as we need to adopt, we need to learn, and we need to find out how to implement them in our projects. And there is an interesting challenge that we now have. I wonder whether anyone knows the answer. It depends. And that has been a source of discussion when they started opening up quite some proposals, because the new situation is that you need to know more about your project. It depends which upcoming features are enabled. And it depends whether you turned on default actor isolation. And knowing what those features do and how they apply to your project and your Swift packages is something really important. And that is my goal today. So I want to let you leave today with all the tools that you need to find out how to use those upcoming features, but also to find out for any new project that you take on, how these work. So let's go back to this list, right? And it's very long, as you can see. But these are the only proposals that relate to Swift concurrency. Some are just convenience, like the task naming one, but the other ones are really dedicated to that vision document that we saw earlier. And if you combine them with a few proposals that we already had from Swift 6 and Swift 5.9, we basically have a collection of proposals that we like to call the approachable concurrency collection of proposals. And approachable concurrency is actually a build setting. So if you go into your Xcode project and you search for approachable concurrency, you'll find this. And it might be turned off for your project because it's an existing project. New projects could turn this on by default. And if you look into the summary, it says enables upcoming features that aim to provide a more approachable path, right? So it really clearly states its purpose. And all the upcoming feature flags that you see on the right side in the summary are related to Swift evolution proposals. So make sure to check them out if you want to learn more about them. Now, this is the vision document, and I highlighted 2 parts. And I actually love this, right? Like, they are honest about it, and they recognize the issues that we've had, and they want to do better, right? So they want to work together with Swift developers. They want to learn from the real world, the real applications, and they really want to improve the approachability of Swift concurrency. And that's why this is also the outcome, right? So the build setting you saw earlier is very much the outcome of the vision document that they released in February. Now, did anyone read the vision document, actually? Okay, quite a few hands. So it's actually a great resource of learning, right? Like many of the new features that we got, they have a background story. And later on with the proposals, you'll see that as well. Like that is such a great source of learning because you really understand why is this new feature here. And many people say like Swift is becoming more complicated. Well, if you better understand why they do it, it might also be more acceptable to accept all the new things that we get. And the things that they also discuss in the vision document are the 3 phases. And it used to be that you start a new project and within seconds you need to add main actor anywhere, or you get like compiler errors because of strict concurrency. And they want to kind of like postpone it. So phase 1 would be writing sequential, single-threaded code. It could be all main thread, for example. Or if you're in a backend environment, it might be one global thread. And then phase 2 would be introducing suspension, but it would be a single suspension. So you wait for that to complete, and then you continue again. And phase 3 is where you start to really introduce parallelism, right? More advanced concurrency, multiple things happening at the same time that eventually return. So I like to simplify this by saying phase 1 is no concurrency at all, right? Phase 2 is we suspend, but without parallelism. And phase 3 is what I would like to call advanced concurrency. And if you think about it, many of the apps, even the simpler apps, or especially the simpler apps, might be fine to run everything on the main thread. And as soon as you hit a certain performance issue, then you start considering optimization. And you might introduce suspension, or eventually maybe even parallelism, right? But you can really build it up. And for somebody starting new with Swift, this is a great improvement. But yeah, these are words. It's a vision document. How does it actually come into place? And before I start to share all those new features, I want to let you know how these work. So in my weekly newsletter, I share an overview of all the proposals, and they go through a few state changes. And this is a great way to, before WWDC, find out what is coming up. Because all those proposals, they were already happening in February. You could already start a discussion, find out what is changing, and even influence the direction. When you click on one of those links, you actually come to an open source GitHub repository. And there's a long list now, because we have many proposals that are already in today's Swift version. And when you open such evolution proposal, there are a few things that you will notice in the top. First up, this example proposal is implemented in Swift 6.2. So you know it's not in active review, it's actually available, and you know which Swift version to use. In this case, you can also see that it relates to a vision document. This is not the case for all the upcoming features, but for the ones related to concurrency, it is. Same counts for the feature flag. Some features are just enabled by default. Like a task naming, it's not an upcoming feature. You kind of opt in via the initializer that is brand new. But for this upcoming feature, you really have to go into build settings and change something in your project. For a good reason, and I'll share more about that later. And like I said before, I really encourage you to check out these proposals. I use them to learn more about the feature, how they work, but also the background story. And if we highlight this line, now this should make you curious to read more about the motivation. Because if you know why they introduced this, you also better understand the outcome that they kind of like seek for. And if you know the outcome they seek for, you also better understand how that code works and how you need to apply it as a Swift engineer. And this is what I like to do. So I copy the feature flag, go into Xcode, and when you paste it, you can actually see approachable concurrency popping up. And it's because it's in the summary, right? So it relates to approachable concurrency. But if you actually want to enable just that feature, you can also search for non-isolated, and the feature itself pops up as an independent upcoming feature. And this is very important. Take note of that. Same counts for Swift packages, right? So if you want to use an upcoming feature in a Swift package, you need to ensure that the Swift Tools version matches up, and you can use that upcoming feature using a Swift setting, as shown in the code example, with the enable upcoming feature setting. I recently did a YouTube video. Luckily enough, I'm not that big there yet, so hopefully you didn't see it yet. But the importance of migration tooling is one of the videos that I shared there. And the thing is, it's such an important thing, but not everybody knows that it exists. And I want to show you why it's important with a code example. And before I start, I want to stress that if you do things manually, it's much easier to make mistakes. Now we have this method, and I'm printing out the current thread. Note that that is a code example that it's an extension because you can't actually print out a thread with Strict Concurrency. If you want to have that code example, I can share that later. But let's see if we actually call it. So here I created a new threading demonstrator, which is attributed with the main actor. So it's isolated to the main actor. And in the demonstrate method, we print out starting on main thread. And as you can see in the slide, it says we're running on the main thread. Then we call into the perform async method, which is an async method on a not sendable class. And I'm sharing a lot here, but we'll get there. Now inside the method, you can see that we print out the thread, which is actually a background thread at this point. It's because we're in a non-isolated environment, so we hop off of the isolation domain. And this is the current behavior. This is how your code probably works today if you didn't change anything of Swift 6.2. When we go back, we're actually back on the main thread because we're back in that class or in that struct that is attributed with main actor. Now, we go into the build settings. We don't use migration tooling. We just enable that upcoming feature. Let's go back to the code. We print out and we start on the main thread because we're still attributed to the main actor. Then we run the perform async method once again. And now, even though we didn't touch the code at all, suddenly that method runs on the main thread as well. And this could cause freezes in your app, your UI blocking. Things that used to run in the background, do heavy work, now suddenly does that on a main thread. And that could even cause an app rejection. Think about it. And I'm over-exaggerated here, but I just want you to understand that if you manually migrate to those upcoming features, this could be the result. If we go back to the demonstrate method, we're back in the isolation domain of the main actor, and we're back on the main thread. This is what is happening behind the scenes, right? So we're still non-isolated, so we're not tied to a specific actor's isolation. But we also don't send the object or the state to another isolation domain. So we don't send ourselves away from the main actor isolation, so we stay on the main thread. And this could also be a tool, and you can also understand that this makes concurrency more approachable. And it's because we stay in the same isolation domain. And not switching off an isolation domain means you don't have to think about sendability. You don't need to adopt the sendable protocol. You don't need to think about thread safety because we're not changing threads. So it already becomes more approachable. And if you tried turning on Swift 6 in the past, you've probably seen like 50 or 60 compiler errors from the get-go. And you fix those, and you build again, and you get another 50, another 50, right? And this is one of those features that should really drastically impact that result. Now, say we do migration tooling, and this is inside an Xcode project. We turn it on, we build the project, and in all the places in our code, we will get a warning hey, this code will be affected by this upcoming feature. So go into that code, have a look, and see if you want this to run on the main thread after turning on that upcoming feature. And they, on purpose, don't do it automatically. They don't change the code for you, because you want to think about each method. It's not always necessary to run something on the background thread. It might have been a non-isolated instance, but maybe that was just a coincidence, right? So think about it per each method, and I'll tell you later how to solve it. If we zoom into the warning, you can see that there's already a suggestion using the add concurrent attribute, which basically says like, hey, restore the old behavior that we had, hop off to a non-isolated isolation domain. And if you want to learn more, you can click the question mark. That will bring you to a documentation environment. And I want you to take note of the sidebar there as well, because right now, there's only 3 features that you can migrate. I spoke with Doc at WWDC, and he told me they're working on more, so I'm still having hope that we get more soon, because the more we can do with migration tooling, the more the tooling can help us, the fewer mistakes we will make. But yeah, this is a great way of understanding the feature. And when you're in that context, read about it before you do any changes. Make sure you really are aware of what you're doing, and save that day for just doing that migration. Don't do anything else, right? The context will help you. So after migration, right, you will see that we add the add concurrent attribute. And if we run that code again, we start on the main thread, we perform the asynchronous method, and when we're in there and we print out the current thread, you can see we restored the previous behavior. And when we go back, we're back on the main thread. So we both enabled the upcoming feature, but we kept the old way of our code, how it used to work. So yeah, migration tooling is really your friend, right? Like, if you have a large project and you need to migrate everything, at first you might think, yeah, I can do that. But if you're doing weeks of migrations, you kind of like want to get done with it, and you go quicker through it, and that's also the moment you will make more mistakes. And you can think like, well, my colleagues will review my code in the PR, but they have a lot of PRs to review, and they might not know the context. Right? So the more you can help yourself by using migration tooling, the better you're off. And existing code could change, right? You don't touch the code, you just change an upcoming feature, and suddenly it all behaves differently. And you might not touch all your code or all your app sections when you test your app, right? So you might not even know how much UI freezes you will end up with. And if you want to know whether you can migrate to an upcoming feature, you can either check out the sidebar of the documentation, or you can just check in the build settings whether a migrate option exists. So back to our original story. We had the overview of all the proposals related to approachable concurrency, and we actually checked 2 of them now, right? Non-isolated non-sending, as well as migration tooling for Swift features. And next I want to look into the default actor isolation. And the joke that I made, main actor all the things, that's actually something you can now turn on via the build settings. Because what it's actually doing, it basically adds main actor behind the scenes to all the instances that you have. So previously this would have been non-isolated. And due to this change, the upcoming feature flag that we had before will not impact our not sendable class anymore. And I can demonstrate that, right? So we now have default actor isolation set to main actor. We go into that async method again, and we can now see that it's running on the main thread. So you can see that the kind of like the new features work together, and you really need to understand the context of your package and your project. And this could be a downside, but it is more control that we can apply when it makes sense. And when we go back, we're back on the main thread. Now the fix is similar to before, right? And probably if you've done the steps that I did, this was already the case. You already added the add concurrent in the places where you need it. So enabling default actor isolation would actually make sense. Now, Many of you will have existing projects. For new projects, I think it makes sense. If you know, like, it's an app, use default actor isolation set to main actor. But for existing projects, you might want to rethink that. You probably did a great job already on threading. There might be a better path towards strict concurrency. So it's really a case by case. I have a RocketSim UI package. Totally makes sense to make that main actor, because otherwise I will probably add main actor everywhere, because they are all UI-related instances. So really take that case by case. So the final proposal from this year's Swift 6.2 release is about global actor-isolated conformances. And this is solving another pain point. You migrate to Swift 6, and you're getting closer and closer, but there was that final itch that you couldn't solve. It was basically not possible. And I'll show you what I mean. So we have a person view model here attributed to the main actor, and we add an equatable conformance. And you might think that this looks all good, but we will get a compiler error. And this is because we're adding an extension to person view model, which is attributed with the main actor. And we can't just add a non-isolated conformance to the equatable protocol. So the fix is actually quite simple. If we pick one of those three suggested fixes, this would be one of them. So we kind of opt out to the main actor isolation by saying, like, this is a non-isolated method. And your project will build again. Now, maybe you want to improve this method by adding the name comparison as well. And if you look carefully, you can see that the name is actually mutable. So this could be changed on the main actor while you access it. And if you change something while it's being, or when you access something when it's being changed, well, you know what will happen. It will be an exception potentially, and that's when your app crashes. And this is also a great demonstration how Swift kind of forces you to have data threats, threat safetyness, kind of data race safety. The compiler error that we get is not really explaining. I wish it was a little bit better. But the way to solve it is actually by using that new proposal. And what we're basically saying, after removing non-isolated as well, person view model now becomes equatable when you try to compare it on an isolation domain that equals the main actor. In simpler words, you can compare it on the main thread. And if you don't do that, say you're on a background task, you will get a compiler error, compile check safety, once again, right? So this really helps us to make concurrency more approachable. So I now want to switch gears a little bit, and I want you to get the best way to migrate to approachable concurrency. And you see what's happening. It's in a way, it's kind of magic. And I learned quite a few things about all those settings in build settings, that you can do some dynamic settings, so to say. But don't do this. The thing is, it will enable all those features. So your existing code will suddenly behave differently. It's the same as just turning on that non-isolated, non-sending to yes without migrating, right? So be careful with changing this setting. Instead, I want you to enable the features one by one. You know, focus on that context. Open a PR for just that feature, right? Learn about that feature, make yourself familiar with it, and apply those changes. And only enable that approachable concurrency build setting in the very end. And you might not even want to enable it. Maybe you want to keep full control, because imagine a future Xcode version adding another thing to approachable concurrency. That certainly changes your code. I hope they won't do that. I hope it won't work like that. Maybe like approachable concurrency version 2 or something. But I like to be in control, so I like to do this manual. So I will give you a few migration strategies that work for me. And this is kind of a mindset. You might recognize this slide from my last year's presentation. But if you do something every day, over the whole year, you will improve a lot, right? So if you touch a piece of code and you're not actively migrating to strict concurrency, you might want to consider migrating that piece of code. And that way you will step by step migrate to strict concurrency. There are a few migration habits that I like to use. And the first one is don't panic, right? especially if you see all those compile errors. And I think many of us been there, and that's probably why not many hands went up. We're all like, yeah, why would I? There's so many compile errors. We need features. We need to build features. But if you break it into smaller steps, right, focus on a few classes, or maybe only your purchase flow or something like that, then you make it more approachable to get to approachable concurrency. Think about doing sendable by default. I do it, for example, for response objects, right? I add the codable protocol, but I explicitly also add the sendable protocol. And that way, I kind of like prepare my code already for the time that I actually want to share it across isolation domains. And it's this relatively easy step. You're in the context of the code either way. And maybe it also prevents you from creating more tech debt in the future. Resist the urge to refactor. You will touch up a lot of old code. And even though we're proud on all the code that we write, you'll see code that you wish you wrote differently, which is fine, but make a note of it, right? Create an issue on GitHub and revisit it later, because you want to stay in that same isolation domain for, that's a bad wording, but you need to stay in the same context. You're migrating to strict concurrency to a certain upcoming feature, and you don't want to distract yourself with a refactor that will always become bigger than how you thought it would be. And focus on minimal changes, right? Like open a PR with just a small change. Don't feel bad about it. Hopefully you agree, maybe not, but I like to do this because, you know, I can leave it behind me. I know this code is migrated. I'm done with it. And it keeps my code changes easy to overview, and it's also easier for your colleagues to review your PRs. And maybe this is, you know, too small, but think about 2 or 3 files or just a single package, you know. Keep the context simple. And if it's all like adding concurrent everywhere, then it's also easier to review, right? But if you're doing in one PR all kinds of changes related to concurrency, it becomes more difficult to review. New project, make it Swift 6.2 by default, right? Enable strict concurrency from the get-go. Prevent yourself from adding more code that you need to migrate eventually. And don't just main actor all the things. So using approachable concurrency by migrating existing code is a little different, right? I like to suggest to start in an isolated environment, which could actually be your top project, because if you think about it, nothing depends on it. Whereas if you do like an extensions package, you might have all those other projects depend on it as well. So it might very well be, if you suddenly make that all async and using concurrency, you will create a rabbit hole where you need to update all those dependent packages as well. Slowly migrate to strict concurrency. We didn't really dive into this, but these are like steps to gracefully enable the strict concurrency checks. This is something you want to do for each project step by step, and it, you know, allows you to gracefully migrate to Swift 6. Then enable the upcoming feature that you want to migrate to. And it's a bit of a chicken egg, because some of the upcoming features require Swift 6.2, but sometimes you don't want to enable 6.2 before enabling an upcoming feature, right? But be aware that you need to do this as well as part of the migration. And this could be a loop, right? You find the isolated code, you increase the strict concurrency checking, you enable an upcoming feature, and you turn on Swift 6.2. And you repeat. And maybe I should add open a PR in between. But this could be a repetitive story. And it's also fine to reset, right? So say you turn on that non-isolated, non-sending feature and you see like 40 warnings. It's fine for that day to just fix 10, open a PR, turn back off that build setting, and continue at a later point, right? Maybe it's a Friday, you don't want to start a big new feature. Might be perfect to use those 2 hours to fix a few of those warnings. And that's once again that 1%, right? Step by step, we get to a better version of the project. I also want to share a bit of an experience, because I migrated 20 plus packages to prepare this talk, but also to, you know, migrate my project and to actually know what I'm talking about. And it's not always as good as you might think. I on purpose highlighted sync here because I used combine in a few places, and compile time checks were all fine, right? No warnings, no errors, everything was good. And I released the app, and I would expect like fewer crashes to appear. But it turned out I actually introduced a few more crashes. Learn by shipping is what I do as an indie, which is fine. And luckily enough, my audience are developers, so I get like great bug reports. But in this overview, it says block was expected to execute on queue, and Apple has to do a better job here. And what I actually did is I had like a pipeline, a combined pipeline with a sink in the end, and I basically called a method that was attributed to the main actor, and I was allowed to do that. So it didn't tell me, hey, you need to actually be inside the task. And I don't want to go too deep into this. I wrote a complete article on this, and I'm not sure. I think in 2 minutes you will have the message in your Slack channel with the link. So you can check that out on yourself if you use Combine as well. It's also easy to make mistakes. So look at this code. Who sees the mistake? So it's a for await loop, right? It's not a regular loop. It's actually this. And once again, no compiler error, no warnings, everything was running fine. But the thing is, this for await runs once, and if it doesn't find an active application, or it doesn't find a bundle identifier that I should update for, it would return, which breaks the for loop. And any future notification in that stream will not be getting into this for await loop anymore. So the fix was using continue. Right? It's super easy to make this mistake, especially when you migrate 20 packages, right? You want to get done with it. And it's not the only mistake. I've actually seen multiple of them. I created a course as well, and I've got feedback from my students as well. And I created a 5-day free email course that you can follow along. Each day you will get one of those mistakes, almost like an article, and I'll teach you how not to make that mistake. And the QR code is still in the corner if you want to scan it. But these are the mistakes, and some are easier to make than you might think. Especially mistake 5, which I like, in an onAppear in SwiftUI, calling an async method. If you've done that, if you're guilty, make sure to check it out. And I got another QR code. This is a different one. It will also bring you the playbook, but I want to do a giveaway for this conference. You will also get the links to all the resources. If you scan this, I will make sure that Klaus can announce the winner later today, but I'll give away access to the Strict Concurrency course. And yeah, with that, I want to thank you for your attention, and have a great rest of the conference.
I like that you mentioned chicken and eggs problem, because this guy has 8 chickens.
Yeah, sorry, I'm a bit opinionated. Yeah, 8 chickens. Yeah.
Also, your pizza ingredients. The Italian guy on my side said they are sendable, but to the trash.
Yeah, I know. Yeah, sorry for that.
So maybe we have just one quick question, because then we're gonna go to the break, to the not to the pizza break, but to the.
This is the difficult part.
Thank you for a very insightful talk. And very quick question. Did I understand correctly that turning feature to migration actually enables it with a warning?
It doesn't enable it, because it only scans your code. It basically scans like, okay, what instances are currently non-isolated? Does it has an async method inside? Throw a warning. So it informs you like, hey, be aware, if you turn it on, these methods will certainly behave different.
Thank you. So feature remains disabled, just produces warnings.
It's really an intermediate step, right? So you turn it to migrate, you build, you scan all those warnings, and then you either need to go back to no or yes. And you could say, like, I keep it to migrate, and it will remain no, but you will still have the warnings, which could be a nice way to, always remind yourself about those still existing. Yeah.
Thank you very much.
You're welcome.
All right. For any other question, just
approach me.
Right?
I love to meet you all, so feel free. Easy to find.
Approach him.
Yeah. I won't hide. Yeah.
Wave. And so we'll go for a break, and then we'll come back with Thiago and creative coding.
Nice.
Let's go.
Thank you.